Well, hi guys. Today we're going to have a look at factorising quadratics by completing the square. Hopefully you'll be aware of how to complete the square after we finish with this. Sometimes, guys, we find that quadratic trinomials will not factorise into whole number factors. I know, shocking, but true. Sometimes they're in between whole number factors and we have to find out a way of getting to those in between factors or in between whole number factors, okay? So yes, we may still want to find the factors, and it's achieved by converting the quadratic into what's called turning point form. And then once we've got it into turning point form, it's then possible to factorise it into a difference of two squares. In some cases, but not in all, but the ones we'll give you to practice on, it will be possible in every case, okay? Alright, the general form of a quadratic trinomial, as you know by now, is y equals ax squared plus bx plus c. Now, the turning point form of a quadratic is quite different. It's y is a, that's some constant, into open bracket x minus another constant, all squared, plus a third constant. And it's so called turning point form because this point here, h and k, k, whatever those numbers are, then this point, h and k, is the turning point. It's called the turning point because it's the point where the graph turns around and goes in the other direction. For example, if I show you here, the graph is coming down, 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 down as we go, moving right across the in the x direction, positive x direction. And now it's going back up again, and this is the point at which it turned around from going down as we move from left to right in an x direction to up as we move from left to right in an x direction. Okay, that's the point. That is the turning point where it turns around. It's also called the vertex. Okay, all right. Now, completing the square is a way of factorising quadratics into binomial linear factors. That is, the linear factors, the factors in the bracket. The binomial means there's two terms. Bi, two, nomial, number. Two numbers in each of those brackets, as we've been seeing, as we've been factorising them. Yeah? Okay. Now, here's the rules for completing the square. I'm going to do one as we go along. It's quite a complicated one, so just grit your teeth and we will conquer, okay? Now, we're trying to factorise this thing here, 2x squared plus 16x minus 23. All right, let's go. First thing you do is you look to see if there's a coefficient other than 1 on the x squared term. If there is, you factorise that out as a common factor straight away, okay? I'll show you. That's right, you take it out of the bracket and that leaves us x squared, and then from the second term it leaves us 8x, and even though this third term is not naturally divisible by 2, we force it by dividing by 2 because you're multiplying by 2 out here. Okay, so we end up with 2 times half of everything that was there in the original expression. Okay, because when you multiply by 2 outside the bracket, of course, you have to divide by 2 to compensate inside here. Yeah, x squared, half of 2x squared, 8x, half of 16x, and 23 over 2, half of 23. Okay, or minus 23 over 2, half of minus 23. All right, that's the first thing you do, guys. Okay, now, what we then do is what's left inside the bracket here, this quadratic trinomial which is inside the bracket, we then deal with the coefficient of the x term, which in this case is 8. You take that 8, you halve it, and you square the result. Now the result that you get, you add, and then immediately subtract this number from and to the quadratic trinomial in the brackets. Confusing? Yes. Well, don't worry, look. This is what you do. We took this coefficient, we got 8. We halved it, you get 8 over 2, or 4, and then you add it and subtract it immediately to the expression you have inside the brackets here, together with what was already there. Now, if I add it and subtract it, I'm not really doing anything to change the value of what's inside those brackets, am I? No, I'm not, okay? But so therefore you're asking me if I'm stark raving mad, why did you do it in the first place? Well, the reason I did it is because I want this number here, okay? that number there makes these three terms here a perfect square, which is what I'm trying to do. So let me show you. That's what you get, okay? 8 over 2 is 4. 4 squared is 16. So it's 2 times x squared plus 8x plus 16 minus 23 over 2, which is already there in the first place. Now, I want this plus 16 because it turns that little beastie there, x squared plus 8x plus 16 becomes a perfect square, which is what I'm trying to do. I'm completing the square by coming up with the third number here, which matches those two terms to make a perfect square. That's what I'm doing. So we've generated a perfect square. The first in the first three terms. Yes, that is equal to that. Okay, so the plot thickens. Now what we do now is we separate the perfect square terms from the other terms so that the perfect square is expressed as a perfect square like this. So what did I do? I harvested or collected those three terms, expressed them as a perfect square, and then the rest of it's just basically what's left over. And I combine those terms together now. I'm getting very close to my difference of two squares, guys. Yes, so it's 2 times x plus 4 all squared. Now, I want to get them both over 2 because I've got to combine these terms. So 16 is 32 over 2 because I already had 23 over 2. That'll combine to make, what will it make? 55 over 2. Excellent. Now, guys, you're looking at this and you're thinking, so what? Well, the what is that that's a perfect square and I can force that to be a perfect square. It's not exact. It's not an exact whole number perfect square, but I could say that that is the square root of 55 over 2 all squared. Let me show you. Yes, express it as a difference of two squares. I know it's looking beastly, but I told you it was a bit complicated. But look, the cookbook recipe is very simple, and when you practice them, you'll get really great at them. So it's 2 times the perfect square minus this thing which I was just talking about before. The square root of the thing squared gets you the thing. That's what I'm saying, yeah? If you're not sure about that, try it with whole numbers. You'll see that it works. E.g., all right, let's take 9. What's the square root of 9? 3. And what is 3 squared? 9. So therefore, if you take the square root of 9, which is 3, squared, you get 9, which is kind of similar to this thing we're doing here with this 55 over 2, right? The square root of it squared gets you to the thing, right? All right, I hope I haven't thoroughly confused you, but we're one step away from our marvellous factorisation miracle. There it is. There it is. Look at it in all its, I was going to say finery, you might say horror, but that's it. We factorised it into linear factors, right? Linear factors. That's what we're trying to do. So you can see they're not whole number factors, not by any stretch of the imagination, but that's them. We've just completed the square, and it's quite marvellous. Now, come on, we'll do some more practice, and then we'll get out of here, and you can do some more practice by yourself and get very good at them. Now, what have we got here? Okay. Now, I'll go through the rules. We don't have a coefficient of more than 1 here, so this one's, we don't have to worry about that first step of factorising out the coefficient because it's 1 anyway. Yeah, like we did on the previous example. So, okay, what we do is we say, what's this coefficient? Okay, it's 8, just the number is what we want. So 8, half of 8 is 4. 4 squared is 16. So we go plus 16 minus 16 and just leave that alone because we want this 16 to make all of those three terms there into a perfect square. Okay, that's right. So that's x minus 4, because this is a minus here, that makes this a minus in here. Okay, if you don't believe me, multiply that out again and prove to yourself that x minus 4 times x minus 4, or x minus 4 squared, gets you this. Right? Now I've combined these two terms here, these leftover terms, the minus 16 and the plus 3 to make minus 13. Now I'm nearly there now. I'm nearly there. What do I do next? You think. Yes? Did you think that? Well, that's great if you did, because now I've got a difference of two squares, and I can now factorise that in accordance with the rule for the difference of two squares. It's the first thing minus the second thing, times the first thing plus the second thing, and there's the answer, and thank you, Mr. Box. for that. Alright, you see? It's not that hard really. Let's do b now. We're on a roll. Again, the coefficient of the x squared term is 1, so we don't have to worry about that first step of factorising out the coefficient. Okay, so now guys, we've got a 5 is the coefficient of the x term. And you might be quaking in your boots thinking, goodness, that's not a whole number. But don't worry about that. You can still halve it and square the result. Just call it 5 over 2 for the half and then square that, and that's what you get, you see. We add 5 over 2 all squared, subtract 5 over 2 all squared in that line. Now we clean it up a little bit and we get this, right? 5 squared's 25, 2 squared's 4. Yes, so we add that and subtract it straight away, and then the plus 2 was there already. Yes, now this term is the one we want to complete the square for this quadratic trinomial. Yes? So you think, what is the next line going to be, guys? You think about it. Here it comes, here it comes, here it comes. Da-da, da-da. There you go. So it's x plus the square root of this term, or this term in here, all squared. Okay, x plus 5 over 2 all squared. Again, if you care to multiply that out, you'll see that it comes to that. Right, now we're going to combine these two terms here by putting them over 4 firstly. 2 is 8 over 4. I've already got minus 25 over 4, so think about that. What's 8 from 25? What does it come to? 17, minus 17 over 4, I think. Yes, that's right. Now we're nearly there, guys. Are you aware we're nearly there? Well, we are. Come on, what's the next line? Yes, sirree, it is. Now, see, look, the square root of 17, well, is just root 17 because that's not a whole number square. So you just call the square root of that root 17. However, the square root of 4 is 2, so we can just put it as 2. Okay, so the square root of this beastie here becomes root 17 over 2. And we're squaring that, aren't we, to get that. Yes? Alright, now come on, what's the next line? What is the next line, guys? There it is, okay? There it is. You agree? The first thing minus the second thing times the first thing plus the second thing, and there is your answer. Is Mr. Box anywhere? Oh, hello, Mr. Box. There you go. And what I've done there is just a final bit of neatening up. I've put these terms on the numerator all over 2 here, which is exactly the same as this. It just looks a bit nicer. So there you go. You happy? Great. All right. So now part C for you and me for free, and looks like we've got this rotten coefficient here to take care of. So let's do that first. All right. We'll factorise that out. So you have to do that if the coefficient of the x squared term is not a 1. All right. So what did I do? 2 times half of everything, right? X squared plus 4x minus 5 over 2. Okay? Now we've got to do the completing of the square on what's in here, just as we've been doing, okay? Alright, so you've got to think, what's half of 4? It's 2, isn't it? What's 2 squared? 2 squared is 4, so I'm adding and subtracting 4, okay, to the expression, and I haven't changed the value of the expression, but again, I need this 4 to complete the square with this quadratic trinomial. What will it be now? How would you re-express that, guys? Do you know? Come on. Well, it's x plus the square root of this number, all squared. Okay? And it's a plus because that's a plus. If that was a minus, it'd be x minus in the bracket. Okay? There it is, there it is. Okay, now I've changed the 4 into 8 over 2 because I've got something over 2, so I want to combine these two terms. 8 plus 5 is 13, so it'll be minus 13 over 2. Great show. Now we've just got to express this thing as something squared, and we're done. Terrific. Yes, that's how I did. Do you agree with that? Because neither of those numbers is a whole number, a square of a whole number, so that's just going to be root 13 over 2, all squared, to get 13 over 2. Now I can do the old difference of two squares rule. First thing minus the second thing times the first thing plus the second thing, and you get that. And Mr. Box is on the job again. Thank you, Mr. Box. Well, it was a bit intense, wasn't it, guys? But, you know, we got to the end, and the end is our friend, and we'll just follow the trend. And we'll get there. We'll get there. please do plenty of practice and get good at these, because if you're going to continue on with your journey of mathematics, which includes this kind of thing, you need to know how to do this like the absolute back of your hand, I'm telling you. Okay? All right. Well, thank you for coming to see me today. Have a wonderful day, and we'll catch you next time.